Water management in agroforestry systems. Agroforestry is an integrated land management approach in which trees, crops, and often livestock coexist within the same productive system. Effective water management in such systems is crucial, as the presence of trees and the multi-layered structure of vegetation influence the water cycle, soil moisture levels, and the overall stability of production. The role of vegetation in the hydrological cycle. Vegetation plays a critical role in regulating the amount of water available in the soil, significantly affecting the water cycle and soil moisture in the following ways. 1. Improved infiltration. The deep and extensive root system of plants create pores in the soil, facilitating the penetration of rainwater to greater depths. This allows for gradual water storage in the soil, enhancing the availability to plants even during periods of drought. 2. Reduction of surface runoff. The shade provided by tree canopies and the presence of herbaceous vegetation reduce the direct impact of raindrops on the soil surface. In this way, erosion is limited, water losses are reduced, and soil structure is protected. 3. Recharge of groundwater aquifers. The greater amount of water infiltrating the soil feeds groundwater aquifers, contributing to the replenishment of underground water reserves. This improves water availability for crops and ecosystems over the long term. Water harvesting and retention techniques. In agroforestry systems, various water harvesting and retention techniques are applied to maximize the use of available water. These include 1. Terraces. Terraces are mainly applied on sloping lands and hillsides where natural gradients increase the risk of surface runoff and erosion. By forming these flat steps, the speed of water flow is significantly reduced, allowing rainwater to infiltrate gradually into the soil. This improves soil moisture and enhances crop stability, while simultaneously limiting erosion and nutrient loss. 2. Microbasins around cultivated trees. These are formed around trees to retain rainwater, especially on sloping soils in semi-arid regions. 3. Furrows or water diversion channels. Furrows or channels are used to collect and direct surface runoff to specific areas where it is needed. They are often constructed in fields, on slopes, or in areas with reduced moisture to guide water to irrigation zones or to spots where the soil has a greater need for moisture. In this way, soil erosion is reduced, water distribution is improved, and soil absorption is increased, contributing to the maintenance of soil fertility and moisture. 4. Flow retarding check dams. These are small structures placed in streams or gullies to reduce water velocity. When water flow is slowed, its residence time in the soil increases, facilitating greater infiltration and moisture retention. Intercropping and soil cover. The selection of plants with complementary requirements and different root system is essential, as it allows for more efficient use of resources and contributes to the maintenance of soil moisture and stability. The techniques used include 1. Soil cover with herbaceous plants or understory vegetation. Low vegetation reduces water losses through evaporation and helps maintain stable soil moisture. 2. Intercropping trees with annual crops. Intercropping is a practice in which trees and annual crops coexist within the same farming system. Trees, with their deeper root systems, provide shade that limits soil water evaporation, while at the same time their roots exploit water and nutrients at different depths than annual crops. This system increases the efficiency of the agroecosystem and improves soil moisture and structure. 3. Use of plants that improve soil structure. Certain plant species can improve soil structure by increasing organic matter and enhancing soil cohesion. Such plants increase water holding capacity, contribute to the creation of porous soil, and facilitate water infiltration. Erosion prevention. In agroforestry systems, methods are applied that protect the soil from erosion and preserve its water reserves. The main erosion control measures include 1. Biological barriers of trees and shrubs. The strategic planting of woody species in lines or strips perpendicular to the slope reduces the speed of surface runoff, retains soil, and allows greater water infiltration. 2. Enrichment of soil with organic matter. The addition of organic material, such as compost or plant residues, improves soil structure, increases water retention, and enhances particle cohesion, reducing the risk of erosion. 3. Crop rotation and diversity of plant species. Alternating crops and avoiding monoculture limit the depletion of soil moisture, while different root systems contribute to soil stabilization and erosion reduction. 4. Creation of terraces. The flat surfaces formed reduce the speed of surface runoff, protect the soil from erosion, and provide stable ground for cultivation on sloping lands. Ecological and productive benefits. Effective water management in agroforestry systems contributes to a range of long-term benefits, both environmental and productive. 1. Stabilization of water resources and mitigation of drought effects. Increased water infiltration into the soil and better storage at greater depths help reduce period of water stress, allowing plant access to water for longer periods. 2. Increased long-term productivity. Stable soil moisture and improved soil quality enhance crop vitality, leading to more efficient growth and higher, more stable yields over time. 3. Reduction of erosion and enhancement of soil fertility. Root system and soil cover stabilize the soil and help retain nutrients. 4. Creation of a more favorable microclimate. The shade provided by trees, combined with the multi-layered structure of vegetation, reduces evaporation. This helps maintain higher soil moisture and contributes to milder and more stable temperatures within the agroecosystem. 5. Enhancement of biodiversity. The presence of many different plants, life forms, and microhabitats create a richer and more complex ecosystem. This diversity attracts beneficial organisms, strengthens ecological balance, and makes the system more resilient to diseases, pests, and climatic stressors.